What actually separates the English, Scottish, Welsh, and Irish at the level of DNA? For centuries, the accepted historical view treated these groups as branches of a single population. Medieval chronicles, early modern historians, and even 20th century textbooks describe the peoples of the British Isles as variations of Celtic or Anglo-Saxon stock shaped mainly by language, politics, and later national identity. This interpretation made sense. Written sources emphasize migrations like the Anglo-Saxon settlement, Viking raids, and Norman conquest. Physical anthropology offered little resolution, and genetics did not yet exist as a tool. Differences were assumed to be cultural first, biological second. That confidence began to crack in the late 20th century, not because of new texts, but because of bones. Archaeological cemeteries across Britain and Ireland revealed something subtle but persistent. Burial practices, settlement continuity, and material culture showed long-term regional stability even in periods traditionally described as massive population replacement. Anglo-Saxon grave goods appeared in eastern England, yet underlying settlement patterns often continued uninterrupted. This raised an early mystery. If entire populations were replaced, why did so much of daily life remain unchanged? The first genetic studies of the British Isles, conducted in the 1990s using Y chromosome markers, tried to answer this. Researchers believed male line DNA could trace invasions directly. Early results suggested higher frequencies of continental European markers in eastern England, and more continuity in Wales, Scotland, and Ireland. This seemed to confirm the traditional model. Anglo-Saxons replaced Britons in England, while the Celtic West endured. But the data was thin, and the samples were small. A major shift came in 2002 with the establishment of the People of the British Isles project, led by geneticist Sir Walter Bodmer at the University of Oxford. Instead of focusing on modern national identities, the team sampled individuals whose grandparents all came from the same rural area. The goal was to strip away recent migration and reveal deeper structure. What they found challenged nearly every assumption. The genetic landscape of Britain did not divide cleanly along modern borders. Instead, it fractured into fine-grained regional clusters. Cornwall separated clearly from Devon. North Wales diverged from South Wales. The North Highlands formed a genetic island distinct from the Lowlands. England itself was not uniform. The East, West, North, and South carried measurable differences that predated the formation of England as a state. This introduced a new mystery. If these populations were so closely related historically, why did DNA preserve such sharp regional boundaries? The answer lay deeper in time, long before England, Scotland, Wales, or Ireland existed. Archaeology places the first permanent settlers of the British Isles after the last ice age, around 11,000 years ago. These Mesolithic hunter-gatherers left stone tools and campsites from southern England to Ireland. For decades, scholars assumed they were later absorbed completely by incoming farmers from continental Europe. That belief changed in 2018. In that year, a landmark ancient DNA study led by researchers at Trinity College Dublin and Harvard University analyzed skeletons from Ireland spanning the Mesolithic to the Bronze Age. The results showed that Ireland's earliest farmers replaced most local hunter-gatherer ancestry, but the later Bronze Age migration, linked archaeologically to the Bell-Beaker phenomenon, replaced much of that again. This population carried steppe-related ancestry that still dominates Irish DNA today. Before this, Irish distinctiveness was often attributed to isolation. Afterward, it became clear it was shaped by multiple large-scale prehistoric population turnovers. Britain followed a similar but not identical path. Ancient DNA from Neolithic and Bronze Age skeletons in England, Wales, and Scotland revealed the same steppe-related influx around 2400 BCE, but its impact varied by region. Eastern and southern England absorbed more of this ancestry. Western Britain and parts of Scotland retained higher proportions of earlier Neolithic ancestry. These differences became locked in by geography and later reinforced by social boundaries. This reframed the question entirely. The key genetic separations were not created by medieval kingdoms, but by prehistoric migrations layered unevenly across the islands. Still, this did not fully explain the sharp distinctions between, for example, the Welsh and the English. Language offered a clue. Wales retained a Brittonic language long after English spread across eastern Britain. For decades, historians debated whether this survival reflected cultural resistance or population continuity. Genetic evidence now suggests both. Studies published in Nature Communications in 2015 showed that Welsh populations share closer genetic affinity with Bronze Age Britons than most English populations do. This doesn't mean the Welsh are pure descendants, but it does indicate less genetic turnover after the early medieval period. The same pattern appears in Scotland, but fractured. The Scottish Highlands and Islands form one of the most genetically distinct regions in northwestern Europe. This was once attributed solely to isolation. However, ancient DNA from western Scotland suggests continuity from early medieval populations, combined with limited later gene flow. The Lowlands, by contrast, align more closely with northern England, reflecting shared migration and political history. Ireland presents yet another case. Despite Viking and Norman presence, genetic studies show remarkably low Scandinavian and Norman input into the Irish population as a whole. This contradicted long-held assumptions based on historical narratives of conquest. Archaeology explains why. Norse settlements in Ireland were urban and coastal, focused on trade. They left strong cultural footprints but limited demographic impact. DNA confirmed what material culture hinted at. This leads to a critical correction. English, Scottish, Welsh, and Irish populations are not separated primarily by the invasions most people think of. Anglo-Saxons, Vikings, and Normans mattered, but they did not erase what came before. Instead, genetic differences reflect how prehistoric migrations were distributed, how geography constrained movement, and how later societies reinforced boundaries that already existed. Yet one mystery remains unresolved. Despite thousands of years of movement, trade, and conflict across short distances, genetic boundaries within Britain remain unusually sharp. The border between England and Wales, for example, aligns closely with a genetic divide that predates the political border itself. Why did these boundaries persist when others elsewhere in Europe blurred? Some researchers point to landscape, mountains, wetlands, and poor soils limiting interaction. Others argue for social structure, kinship systems, and local marriage patterns reinforcing separation. The evidence supports both, but neither explanation fully accounts for the precision of the genetic lines. What is clear is this: DNA does not confirm national myths, nor does it erase identity. It reveals a deeper story, in which English, Scottish, Welsh, and Irish identities are built on populations shaped long before those names existed. The differences are real, measurable, and ancient, but they do not align neatly with flags or borders. If prehistoric migration set the genetic foundation of the British Isles, why did later historical events fail to overwrite it?